Alright, we're back. We're working on practice exam number 2 from Physics 211. Number 8 was a requested problem, so I'm going to go ahead and work through that one. Number 8 states that an airplane pilot experiences weightlessness as she passes over the top of the loop maneuver. If her speed is 200 meters per second at the time, find the radius of the loop. Alright, so we've got some sort of a semicircular loop of some radius r that we're trying to solve for. Now we know that her velocity at the top of the loop-de-loop is going to be 200 meters per second tangential, okay? 200 meters per second, and that's going to be a tangential velocity. So right off the bat, you should be thinking, hey, tangential velocity radius, there's going to be some acceleration, centripetal, going on here that's keeping her towards the center, AC. And we know that AC is equal to velocity tangential squared over r. So this equation shows up a lot in this past couple of sections. So now the trick here is to do a free body diagram. So I want you to think, if you're going over this loop, I mean, mg is always there, right? So we've got, when we're looking at the top of the loop, or any point of the loop, mg is always a thing. And it's always pointed downwards, orthogonal to the ground, if it's flat ground anyhow. And then you may think that there's a force up, like a normal force up. You could really assume it either way. Personally, when I'm going over a loop, like for example, if I was on a Ferris wheel, my normal force would still be up when I get to the top of the loop. But if I was on like an inverted roller coaster, my normal force would be downwards, right? So if you're upside up when you're on the top of the loop, then your normal force is up. If you're upside down, your normal force is down. And then of course, if you guess incorrectly, which is entirely possible, the math will just spit out a negative and let you know that you picked the wrong direction. But for now, let's just, and it doesn't really even matter because we'll see in a second why it doesn't matter, but there's two forces, the normal force and mg, and then there's an acceleration centripetal, which is not part of the free body diagram. That's why I draw it to the side with a dashed line. But it'll help me when I say the sum of forces in the y direction equals ma. And therefore, we know that we've got minus normal force minus mg equals AC is also in the minus direction if you choose positive up, negative down. So I'll have minus MAC. Well, you'll notice that all the minuses cancel to give us positives. And so what's next is we say normal plus mg equals MAC. And weight. What really is weight? I'm sure Ahab said this, but like for example, if you were on an elevator and going up, if you were stepping on a scale, it would show an increased weight. So mass and weight are not the same thing. Mass is intrinsic. You always have the same mass at a given instant. But if you're accelerating upwards, you have a weight that increases. And so we know that scales measure with springs. And so it's how hard you're pushing down the spring. Well, springs are based on a constant of force, right? A force per distance of distortion of the spring. And so we know that weight is a kind of force. And in fact, you might say that weight is mass times gravity. But that wouldn't give you the whole story. Because right now, mass times gravity is the same in all frames for whoever it is, whether you're doing a loop-de-loop or, going up in an elevator. mg stays the same. But because of this acceleration, our normal force would change. And so really, it's better to call your weight the normal force. Because your weight it will change if you're going up or down an elevator or around a loop-de-loop. So to keep things consistent, we go ahead and say that weight is synonymous with normal force. And so when it says that she experiences weightlessness, what that means is that her normal force is 0. All right. So now we know that m, and let's go ahead and cancel the m's now. So g equals AC. we know that AC is v squared over r, v squared over r, and we know that we're interested in solving for r, so let's go ahead and multiply r over here, divide g over there, and we know it's 200, so 200 squared divided by 9.8, which is g, will give us our radius. So let's go ahead and figure out what that is. 200 squared divided 9.8 is 4,081.6, approximately that many meters. And so that's the answer to this question. It seems like a reasonable answer. I'm a big fan of making sure that my answer seems reasonable. This is a very large distance, but when you think about an aircraft and how much displacement it's getting from its velocity, it's not unreasonable to think that a loop-the-loop might be performed with a radius of roughly 4,081 meters. So anyhow, that's question number 8. I hope this was helpful, and I'll see you next video.